Now students, you see in the first video we have seen that the length resistance is directly proportional to the length of the wire. So we have seen that the R is proportional to the length of the wire AD and S is proportional to the length of the wire DC. R is proportional to what? Length of the wire AC, and S is proportional to the length of the wire DC. Now what will happen? Now from equation 1, P by Q is equal to what is R by S is there. What is R here? R is what? Length of the wire AD. And what is S? Length of the wire DC. So what we have done? From equation 1, we are putting P by Q is equal to length of the wire AD divided by length of the wire DC. So length of the wire AD. What is the length of the wire AD? From this figure, if you'll see, length of the wire AD is what? L centimeter. And what is DC? 100 minus L. क्लियर हो गया? सो AD का जो डिस्टेंस है उसको हम क्या किससे रिप्रेजेंट कर रहे हैं? L सेंटीमीटर से. और DC का जो डिस्टेंस है उसको हम क्या किससे रिप्रेजेंट कर रहे हैं? 100 minus L. So now in this equation, length of the wire AD, what I will write here? L. Similarly, length of the wire DC, 100 minus L. This will give equation number 2. Now compare equation 2 and equation 1. Now what is the equation 1? Already we have seen equation 1 is P by Q is equal to R by S. P by Q is equal to R by S is equation 1. And equation 2 is what? P by Q is equal to L by 100 minus L. So from comparing equation 1 and 2, if we compare equation 1 and 2, what we'll get? On the left hand side of both the equation 1 and equation 2, P by Q and P by Q is there. So left hand side is same, it means right hand side is also same. So in the first equation, right hand side is equal to what? R by S. So it is what? R by S. So R by S is equal to L by 100 minus L. R by S is equal to L by 100 minus L. Comparing equation 1 and 2. Send this S to second side. If you send this S to second side, where S will go? R will become S into L divided by 100 minus L. So R value is the unknown value. The unknown value of resistance is given by SL divided by 100 minus L. What is this L? L is in centimeter. When L is in centimeter, we'll write R is equal to SL by 100 minus L. But if L is in meter, here this formula is for R is equal to SL divided by 100 minus L when L is in centimeter. Now if L is in meter, what will happen to the formula? R is equal to SL by 1 minus of L. So these are the two formulas which we can use. So from this relation, what we have got? We got that how to find out the unknown resistance using the meter gauge. So what is the formula for this? R is equal to SL divided by 1 minus L. When we will be using 1 minus L formula? When L is in meter. And when we will be using SL divided by 100 minus L? When L is in centimeter. So this derivation is completed for what? Unknown, to find out the unknown resistance of the wire using the meter gauge. So unknown resistance of the wire is given by R is equal to SL by 1 minus of L. Next comes uses of meter gauge. What is the use of meter gauge? It is used to compare the resistance of two resistors. Meter gauge is used to compare the resistance of two meter gauge. It is used to measure the resistance of unknown wire. It is used to determine the specific resistance of the resistors. And it is used to verify the laws of resistance in series and parallel combination. Now these are the 4 experiments we have to do for this particular chapter. So already I had told you that this chapter is very important for the case of theory as well as practicals. So all these 4 experiments we have to perform. Uses of meter wedge. So what is the use of use? It is used to compare the resistance of two resistance wire resistors. It is used to measure the resistance of unknown wire. It is used to determine the specific resistance of the resistor, and it is used to verify the laws of resistances in series and parallel combination. तो ये 4 यूजेस हैं मीटर वेज के. तो ये कंप्लीट हुआ तुम्हारा मीटर वेज. So what is the use of meter wedge also we have completed. What is the derivation of the meter wedge also we have completed. What is why meter wedge is called as the meter wedge, that also we have seen. What is the principle of meter wedge, that also we have seen. So fastly I will just revise this topic. Today's topic, today we have completed the meter wedge. So today is the 3.15. Tomorrow we'll start with the potentiometer. So 3.16, the last topic of this particular chapter. So this chapter will be completed, and then tomorrow we'll try to complete the this chapter, and in that the next point we have to study about the potentiometer. It is little bit lengthy. It will take little bit 2 days it will take. So what is meter wedge? Meter wedge is also known as slide wire. It is the practical form of the Wheatstone bridge. What is the principle of meter wedge? It is constructed on the principle of balanced Wheatstone bridge. What is balanced Wheatstone bridge? P by Q is equal to R by S. P by Q is equal to R by S is the balanced Wheatstone bridge. Now what is the construction for this? In the construction side, what we have seen is C is 1 meter wire, constant and wire. This wire is fixed on a wooden board, and besides this, parallel to this, 1 meter scale is connected, so that we can calculate the distance. To this AC, M1 and M2 are the 2 right angle clamp. They are the steel clamps, right angle steel clamp. M3 is the another straight right clamp. It has 3 connections. M1 and M2 is having only 1 connections. So between these 2 points there is a gap. Between these 2 points unknown resistance R is connected. Between M3 and M2 known resistance box is connected. Resistance box is connected. Through this we can find out the resistance. We can plug the resistance from this resistance box, and we can identify what is the resistance of this. And next comes the B point. B point is the point where a galvanometer is connected. One end of the galvanometer is connected to the B, and another end is connected to the jockey J. Jockey is the slider which is sliding on this particular wire. Jockey will be used to find out the null point or zero deflection. So what we have to do when we start, and to this point A and C, battery is connected and a plug key is connected. Positive terminal of the battery is connected to A, negative terminal is connected to the plug key, and to this C is connected. So always in this particular meter wedge, we have to start from positive terminal and we have to move to the negative terminal. So already I have explained this. It is a meter wedge. Uniform wire of resistance wire AC of 1 meter length is connected on the wooden board. It is clamped between the 2 thick right angle metal strips M1 and M3. M2 in between that, which is a straight metal strip M3. M1 and M2 are connected in such a way that there is a gap, left hand gap and right hand gap. On the left hand gap, unknown resistance is connected, and to the right hand gap, known resistance is connected. A resistance box is connected to the right hand gap. Clear? So S is a standard known resistance which is connected on the right hand gap. One terminal of the galvanometer is connected to the terminal B, and another terminal is connected to the slide wire J. Jockey it is called. Meter scale is fixed parallel to AC. a battery and a plug key is connected between AC. Then we have seen the working. In the working, D is the balancing point. S is taken from the resistance box. When a known resistance wire is taken from the S, then what will happen? The galvanometer will show the deflection. Now what we'll do? We will start moving the jockey from point A to C, and at particular point a galvanometer will give the zero deflection or null deflection. There will stop. So that distance is given by AD. AD is equal to P, and the remaining distance DC is equal to Q. Then from the Wheatstone bridge we can find out P by Q is equal to R by S. Equation 1. Here we understood that resistance is directly proportional to the length. R is proportional to the length of the wire AD. S is proportional to the length of the wire DC. From equation 1, P by Q is equal to length of the wire AD divided by length of the wire DC. So this will give you what? What is the length of the wire AD? L. What is the length of the wire DC? 100 minus L. You give this as what? Equation number 2. So comparing equation 1 and 2, left hand side of both the equation 1 and 2 is P by Q. So we will get R by S is equal to 100 by L by 100 minus L. Send this S to second side. So R is equal to SL divided by 100 minus L when L is in centimeter. When L is given in centimeter, then we will use this formula. If suppose the L is given in meters, then the formula will be R is equal to SL by 1 minus of L. So this is the unknown resistance. How to find out the unknown resistance using the meter bridge? This is the derivation. Next, uses of meter bridge. It is used to compare the resistances of the two resistors. It is used to measure the resistance of the unknown wire. It is used to determine the specific resistance of the wire, and it is used to verify the resistances in series and parallel combination. तो ये complete हुआ तुम्हारा meter bridge. So tomorrow we will see the potentiometer. So today we have to complete both this derivation. Okay. So next we'll see tomorrow.